Google Gemma4, a small model for private AIs. The prompt to Gemma4 was, write 1,000 words at the 10th grade level about the Gemma4 model. Discuss architecture, training data, and use cases for the model. Sentences should have a maximum of 2 clauses. Always write in active voice. At the end, generate a 75-word executive summary. Speed, 9 TPS with 16 threads on i7 with 32 gigabytes memory, no GPU. I ran in non-thinking mode. Executive summary. Gemma4 is an advanced open weights model from Google DeepMind. It features a multimodal transformer architecture. The 2B and 4B versions process text, images, and audio. Engineers trained it on massive cleaned datasets using instruction tuning and RLHF. This ensures high-quality, safe outputs. Key use cases include software development, personalized education, content creation, and customer service. Its efficient design also supports local deployment on mobile devices and edge computing hardware, needing expensive servers. Article: Google DeepMind created the Gemma4 model. This new technology represents a major leap in artificial intelligence. Developers call this type of model an open weights model. This label means people can download and run it on their own computers. Large companies usually keep their best models secret. Google chose to share the weights for Gemma4 with the public. This choice helps researchers study AI safety. It also empowers small developers around the world. The architecture of Gemma4. The architecture of Gemma4 relies on the transformer design. Most modern language models use this specific structure. Transformers use a mechanism called attention. This mechanism allows the model to focus on important words. It ignores irrelevant parts of a sentence. This process creates a deep understanding of context. Gemma4 uses many layers of these attention mechanisms. The model comes in several different sizes. These sizes include 2B, 4B, and larger versions. The B stands for billions of parameters. Parameters act like tiny connections in a brain. More parameters generally allow for more complex reasoning. Small models run fast on laptops. Large models require powerful servers with many GPUs. Gemma4 uses a technique called multimodality. This means the model processes different types of information. The 2B and 4B versions can process text, images, and audio. This makes the model much more versatile than older versions. You can show the model a photo. You can then ask it questions about that photo. You can even play an audio clip for it. The model listens to the sound waves. It converts those sounds into digital tokens. Then it predicts the next logical word in a sentence. The architecture also uses efficient math operations. Google engineers optimize the code for modern hardware. This optimization reduces the electricity needed for training. It also makes inference much faster for users. Fast inference allows for real-time conversations with the AI, the training process, and data. Training an AI model requires massive amounts of data. Engineers feed billions of words into the system. This dataset includes books, websites, and computer code. The model reads all these documents during training. It learns the patterns of human language. It discovers how nouns connect to verbs. It learns how grammar rules function in different languages. Google uses a high-quality filtering process for this data. Raw internet data often contains errors or hate speech. Engineers use automated tools to clean the dataset. They remove toxic content before training begins. They also remove duplicate information. This cleaning ensures the model stays helpful and safe. The training follows a specific sequence of steps. First, the model undergoes pre-training. During this stage, the model learns general knowledge. It predicts the next word in a massive stream of text. This creates a foundation of world facts. Next, the model undergoes instruction tuning. In this stage, developers give the model specific tasks. They teach it how to follow commands like summarize this or translate that. Google also uses reinforcement learning from human feedback, RLHF. Humans review many different model responses. These humans rank the best answers. The model then updates its internal weights based on these rankings. This process aligns the AI with human values. It teaches the model to be polite and honest. It prevents the model from generating dangerous instructions. The training of Gemma4 also incorporates multimodal data. Engineers paired images with descriptive text captions. They matched audio files with written transcripts. This pairing allows the model to connect visual shapes to words. It connects specific sounds to written meanings. This creates a unified understanding of the physical world. Use cases for Gemma4. Gemma4 offers many possibilities for various industries. One major use case is software development. Programmers use Gemma4 to write computer code. The model understands many different programming languages. It can find bugs in existing scripts. It can even suggest better ways to structure a function. This speeds up the entire coding process. Education provides another great use case. Teachers can create personalized tutors for students. A student can upload a photo of a math problem. Gemma4 can explain the steps to solve it. The model can also summarize long history chapters. It can translate foreign language lessons instantly. This makes learning more accessible to everyone. Content creation is also transforming with this model. Writers use Gemma4 to brainstorm new ideas. Marketing teams use it to write catchy slogans. Social media managers use it to generate captions. The model acts as a creative partner. It does not replace the human writer. Instead, it removes the fear of a blank page. Customer service companies benefit greatly from this technology. Businesses can deploy Gemma4 in chatbots. These bots handle common customer questions instantly. They can understand complex queries about shipping or refunds. This reduces the workload for human agents. It also provides customers with 24/7 support. Researchers use Gemma4 to study artificial intelligence itself. Because the weights are open, scientists can inspect them. They can test how the model handles bias. They can investigate how it stores memory. This transparency is vital for AI safety. It allows the global community to build better safeguards. Finally, edge computing represents a growing frontier. Small versions of Gemma4 run directly on mobile phones. These models do not need an internet connection. This ensures privacy for the user. No data ever leaves the device. Local processing also reduces latency in applications. This makes smart home devices much more responsive. Conclusion. Gemma4 represents a significant achievement in AI development. Its multimodal architecture allows for complex interactions. The training process emphasizes both knowledge and safety. Its open nature encourages global innovation. From coding to education, the use cases are endless. Google DeepMind continues to push the boundaries of what machines can do. This model paves the way for a more intelligent and integrated digital future. Do you know that any private information you put into a cloud AI is used to train that AI? A private AI running on your own hardware is the best way to keep your private data private. I can help you set up a private AI on almost any PC or server. Contact me for a free consultation. If you get value from these blogs, please consider joining my Patreon as a member at the $2, $4, or $8 level. There are more than 400 previous blogs on my Patreon page. https://www.patreon.com/Steve Hovland